For problem number 12, I'm given 2n squared plus 1 is equal to negative n. Remember, to solve this using the quadratic formula, I want to do it like this. I want to make it look like this. I got to solve for 0. And that'll give me my corresponding A and my B and my C. That I'll plug into the formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I solve for 0 by adding n to both sides. That gives me 2n squared plus n plus 1 equals 0. Now, n doesn't combine with 2n squared, they're not like terms, and n doesn't combine with 1 because they're not like terms. In order for them to be like terms, they have to have the same variable raised to the same power. So I'm off to a good start. I have my a term is equal to 2, my b term is equal to 1. We don't have the 1 written there, but it's right there. And my c term is equal to 1. I want to show you guys something just so you can see it real quick. If I graph this, if I say 2x squared plus x plus 1, and I hit enter, I get a very nice graph, but the y-intercept is positive 1. In other words, this never crosses the x-axis. So I'm going to sketch that here on the top of our paper so we can kind of remember what that looks like. I've got a graph that looks like this. It's a little bit off to the side, but it crosses right here. So, you know, it looks like this. And it never really crosses. So what that means is that this has imaginary solutions. Real solutions are the zeros. In other words, there's no real solution. So when I plug this into the quadratic formula, I'm not going to get numbers. I'm going to get i's somewhere. So let's plug it in and see. N should equal negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Fair enough? Now, that means that n should equal negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 2, times c, which is 1. And that'll be 2 times 1. So, I get negative 1 plus or minus. This becomes 1 minus 8. So this is like 1 minus 8, which gives me a negative 7 all over 2 times 1, which is 2. So I'm going to rewrite that as negative 1 plus or minus the square root of 7 times the square root of negative 1 all over 2. Oh, I caught an error. Look at this. It's 2 times a, but a is actually 2, so this should be 4, and this should be 4. So now that means I'm going to have two solutions. I'm going to have negative 1 plus I root 7 all over 4, or I'm going to have negative 1 minus I root 7 all over 4. These isn't always the case, but these two particular when you take a square root, you're going to have two imaginary numbers. And the only difference between them is a plus or minus sign. And so we would call these conjugates. Okay?